this is Henk Akkermans and this is Supply Chain Dynamics Chapter 4, Sysdea Gameplay 6, Inherent Oscillation. What we saw so far is that in this model there's a one-time change in the input, the new order rate, which peaks somewhere around 22 and then goes down again, so a one-time hit to the system. But the system responds repeatedly with going higher and lower, with overreacting indeed to this response. It does so in order backlog, it does so in delivery performance, does so in production output, in capacity, etc. So the notion of a one-time change, which leads to repeated reactions in the model, is one that is, well, you could say the hallmark of oscillation. Now, do we have oscillation in this model? That's the interesting question, of course. What we can do is we can make the settings longer, say at 100, and then see if we can make the behavior such that the historical sales rate up here stays fixed. Oh, more fixed, I'd say. Stays more or less fixed. So we don't have a oscillating input anymore, because this was the beginning of an oscillation. But we have, yes, we have oscillation in the output. The order backlog keeps fluctuating, the delivery performance keeps fluctuating, work in process keeps fluctuating, even the desired capacity keeps fluctuating. Of course, actual capacity is very much a smoother variable, but you see in the rate of change that it keeps oscillating. So apparently, even after we freeze the initial input, we keep having an oscillation here. And that suggests indeed that there is inherent oscillation. You could argue, yeah, but you know, it goes up and down. What if you, perhaps that's the reason we put this in there? Well, we can easily check that by having another type of input, which is this one. So we have one-time increase in new orders. And what you see then is that we still have oscillation at a more modest level, but you see things still going up and down, perhaps less prominently, but the system doesn't flat out. If you want it flattened out, you have to take out the source of the oscillation. Now we know from theory that oscillation occurs when there are at least two negative feedback loops with some delay in there. Now this model has many delays, but if you check step by step or what delays we could change, delays in production planning, you'll find out that if you make capacity fixed, then indeed there is no oscillation anymore. The whole system comes to pretty much a grinding halt. And that's, this shows that oscillation is really caused by the capacity feedback loop. There's such a delay in there that the capacity can't really dampen out, become stable, even if you take out this oscillation test. You now see the new orders, the historical orders, have a bit of oscillation, and then nothing much happens after that. If we go back to 48 months even, you see that we have a very stable response to the system. All this because we turned the capacity adjustment off. And now we're back in the base case. So there is inherent oscillation in this model. And in this case, in other cases it could be different, but in this case it's caused by the capacity adjustment delays.